do my very best to moderate the chat. But over to you, Andy, the 10 do's and don'ts.
Absolutely. So this is the 10 do's and don'ts of sustainable systems design. Bit of a health warning, first of all. I am a software engineer. If I shut my eyes, I do see ones and zeros. So it is going to be quite technical. I want a bit of feedback on the line. Okay, I think I've only got 30 minutes. So by my maths, that's 3 minutes per do and don't. So I better get cracking. The first one, don't think your applications don't make a difference. So to explain this one, we're going to start looking at carbon emissions by industry. Now, there are 4 main polluters: transport, infrastructure, agriculture, and traditional industry. And if these guys don't sort out their emissions, then ICT and the internet doesn't stand much hope. So, as I mentioned, the internet and everybody that works in the web industries falls under the category ICT, information communications technologies. In 2022, Mike Berners-Lee, yes, that is Tim Berners-Lee's brother, the guy who invented the internet. He's also the author of the Carbon Footprint of Everything and How Bad Are Bananas, estimated that ICT makes up around 3 to 4% of global emissions. So ICT, if you unpack that a little bit, what is it? It's things like our laptops, it's things like our mobile phones, and most importantly, it's things like data centers. And this is where a large amount of emissions come from. We have an increasing reliance on data centers as well, with new emerging technology. And I promise Yanis I'd at least drop the word AI in once, but like the emergence of AI and blockchain or Web3, data center emissions and data center usage are going to significantly increase in the coming years, immediately, to be honest. And it's important that we as an industry start to look at our emissions, measure our emissions, and take action to decrease them. So I'm going to start looking at some web design techniques from a software perspective that we can implement to reduce our emissions. First one, don't think that a green approach to systems design is a mutually exclusive benefit. Now, this is the great news bit. So by reducing carbon emissions, I can also promise you'll reduce cloud hosting costs and increase performance for your end users. So the tools we're going to go through today look at a bunch of techniques around reducing reliance on cloud services and increasing user performance. So how big the pages are, how much JavaScript we load in your clients, how close we serve content to users, like the use of the edge and CDNs. So we're going to cover lots of stuff, but bear in mind that all of these things will save your money and your users will have better experience, as well as driving down carbon emissions. Number 3, don't assume that your website is carbon neutral. This is the first place to start. I think everyone always asks me, where do we start with these kind of things? The first part starts with reporting. Now, as part of the greenhouse gas protocol, we're all going to be responsible for reporting on our scope 1, 2, and 3 emissions. And us as a supplier, we are responsible for reporting our scope 3 emissions as we're part of people's supply chains. So the systems we produce for our clients, we're going to need to produce carbon reports for. There's a ton of ways of doing this. We're all cloud first, so it's a bit easier for us, but all the major cloud providers, GCP, AWS, and Azure, they all have carbon reporting as part of billing. So if you're going into your billing information, you'll be able to see your CO2e emissions attached to your billing data. Now, there's a really cool dashboard, which you can see a link for on the screen now, which is called the carbon footprint, from the cloudcarbonfootprint.org, and it's completely free and open source, and it will aggregate all of your billing carbon data from all your cloud providers in one place, so you can start to see over time whether your releases drive down carbon, whether you're like getting less reliance on your back-end services. And this is a fantastic place to start. You should first start by benchmarking where you currently are, looking at your current emissions, and then putting plans in place to drive those down. And it's worth noting as well that depending on your organization, that you will have some significant emissions, and you'll be shocked by this if you're looking at big data, for example, or if you host web applications that have high volumes of traffic, you'll have some significant carbon emissions attached to those. And hopefully later on I'll be able to drop in a couple of stats from some of the clients we've seen and some of the case studies we've seen in terms of reducing them. So then we're going to start off with the UI. So the first point is optimize your UI and client-side scripts. So this is everything that happens inside your browsers. Now, this is one do, but you're getting nine do's for the price of one here. First is take a mobile-first approach. So you should be designing your websites with the worst case browsers or experience in mind. So mobile compared to like desktop, and then take it from there. You should start looking at, from a design perspective, carbon aware design. That's thinking about the number of fonts you use, how bright the screen is. There's a ton of different things that come under the word carbon aware design, but your design team should be adopting that and starting to think about how you adopt that to your UX and UI designs. Number 3, some sites have started using energy saving toggles. You can see one in the top right corner there. That's actually from boohoo.com, I think it is. It's a clothing brand. They've removed it since, but they're not the only brand to do it. And by clicking that, you'll reduce the size of images, you'll reduce the number of fonts, you'll put a dark overlay over the screen, so you're using less energy from your user's perspective on a screen-by-screen basis, and implement a ton of features that might slightly degrade user experience, but from a carbon perspective are certainly optimum. Number 4 is optimize your images. Some of the biggest things you can do is adopt progressive image optimization techniques like WebP, and AVIF is coming on the horizon soon. It's not completely adopted by all browsers, but that will have a massive effect on the amount of data you guys are transferring over the internet, which ultimately is related to carbon emissions. Next one is bundle all of your assets. So your JavaScript assets and everything like that, your CSS, all modern front-end frameworks will do this for you. But by bundling it into single HTTP requests, mean you're making less requests over the internet and ultimately using less carbon as a result. Next is about optimizing your JavaScript. So JavaScript is something that runs in the client. And if you've got a lot of it, your client might have to do a lot of work, and that's going to be directly resulting in carbon emissions for your users. So by optimizing the amount of JavaScript and the runtime of JavaScript, you have a benefit from performance, as I said before, and you'll also be reducing carbon emissions. Limit the number of third-party libraries and fonts you're using. Number 7. Number 8. Turn autoplay off videos. So when you're scrolling down through UX experience, not all videos are automatically starting, which is a really expensive asset to load in, and they're only being played on click. And the last one is load dependencies on events, like click events, rather than on page load. A really good example of this might be something like a chatbot, where a really small percentage of your users engage with it, but there's a large carbon footprint attached to it because of the size of the JavaScript files. Like, you know, the Microsoft chat books have like 4 meg JavaScript files attached to it. You want to bootstrap those files in on click of the chatbot item rather than loading them up for every user on every page load, where only a small percentage might actually engage with the chat. So number 5, don't ignore user data volumes and location. Now, we're going to go back to like how websites work here, but it's important to take this view from a carbon perspective, and we're going to start with a monolithic application. So we have a website and it works in a browser or a client, and here we have, in this example, it's based in the UK where I am. That browser would make a request out via the internet to a web server, this case in Denmark where our friends at Umbraco are. That web server then might be called an application server, which could call a database, and it could call a CMS, and ultimately it will churn and its cogs and produce some HTML and send that back across the wire. Now, at every point across the chain, we need to think about carbon emissions, because there will be carbon emissions at every single point. So we already talked about what happens on the browser from a front end perspective. There's also carbon emissions attached to how far that network request has to go. And again, you also have, from a performance perspective, network latency to think about as well. Every single internal request within the internal networks as well will also have carbon emissions attached to them, as well as the retrieval of any data from any downstream systems and the generation by the web server of said piece of HTML back across the internet. And that's exponentially worse for users on a global scale. So if you start to think of users in the US or China making requests to that server in Denmark, there's going to be significantly more carbon produced as that piece of HTML or piece of data or the request across the internet will have to travel much further. Enter static site generation. There's a lot of talk about static site generation in modern day application development. It's something we adopt here, and it certainly has a very positive effect from a carbon perspective. It can be done with lots of different libraries and tools and techniques. You can use static site generation in Go.net, blah blah blah, React as well, and some of the packages we use are Next.js, and Gatsby is also another big player in the React market. So how does this work? You start off with like a headless CMS, like Umbraco Hardcore. That then inputs into a static site generation application, which will create some HTML. And this is done on publish or delete or unpublish events inside the CMS. So the main difference compared to the previous example is rather than being done by request on the internet, it's done when there's a change to the CMS, to content. That statically site generated content would then be stored inside cloud storage and distributed on a CDN. And then for anything we can't statically generate on request from browsers, we would then make calls to APIs. So rather than the HTML for your pages being generated per request, it's generated once, cached indefinitely until there's a change to that content on the edge and served local to users. And then anything we can't cache or statically generate, for example, something like a share price feed where it's constantly changing, we'll make asynchronous requests back to an API to pull that content in. So now if we look at our previous example, our user in the UK is making now a request to a CDN that's going to be served locally to them. Our user in the US and our user in China is also making requests locally to them, meaning you have lightning fast times to interactive, like point something milliseconds. It's absolutely rapid compared to like traditional monolithic applications and the network latency you have of making a request across the internet. And then for everything else, you would still have to make the request back to the web server of destination of choice, and to an API to retrieve that data asynchronously, but it's much more efficient. We did this for UK Power Networks. They're a power provider in the UK, and we saw load times drop from 4 point something seconds to sub 2 seconds for like full page loads. We also saw carbon emissions drop from 1.44 grams per home page load to 0.22 grams. Now these guys here get a lot of traffic around storms, and Storm Eunice was a big storm that hit the UK and large parts of Europe as well 2 or 3 years ago, and they saw 3.2 million users hit their site in a weekend. Now the carbon emissions saved from the homepage loads alone were the same as 9 flights from London to Copenhagen, and most users in fact would have gone to 3 or 4 pages, so have been much more than that. So in a single weekend you can start to see how you can make dramatic carbon savings at scale. And here's just showing you still have the carbon emissions from like the requests, but they're coming much more locally and being served on the edge on the CDN. And again, you're only making requests back and having the carbon emissions for asynchronous requests, which should be a much smaller percentage. Number 6, do optimize the number of HTTP requests and size of data transferred. Now, this one here is all about APIs, and this is about picking the right protocol. I didn't include SOAP on here, but I've included the example with REST and with GraphQL. Now, with RESTful APIs, you often have endpoints split by domain, and here you can see examples where you have to make separate requests across the internet for information on customers. Then you have to make a separate request to get all of the orders for said customer, and then you might have to make another request to get all of the products for said orders, which is multiple HTTP requests. And back to what I said before, remember, every single HTTP request produces carbon. Now, the good thing about GraphQL is you can aggregate requests into a single HTTP request. So I can get all of my customer and order and product data in a single HTTP request rather than multiple. Again, being much more performant, again, requiring much less usage of cloud systems, so saving you all money, and again, significantly reducing carbon. Number 7, do migrate to SaaS or PaaS. This one here is like the big one, right? This is all about infrastructure, and it's where you can make some of the biggest difference from a carbon perspective. The first one is about migrating your on-premise applications to a cloud service, like or even your on-premise applications to managed cloud services like PaaS or SaaS. Microsoft estimate that you can save 95% in carbon emissions by doing an on-premise migration to PaaS or SaaS. Now, take this with a pinch of salt because it's Microsoft marketing propaganda, and you could definitely optimize your own VMs 100%. But the takeaway here is that PaaS and SaaS infrastructure is shared. You're sharing it with other people, and you're getting a percentage of it, meaning the power that goes into it is also shared, and the carbon emissions are shared, and it's much more optimized than if you're running your own VMs and infrastructure. Also, you can start to look at like service design of your applications and look at microservice architecture. And this is where you start to see some huge benefits compared to the monolithic application before. Say, for example, you had a monolithic application where all of your services are in one big lump, one big application, but only a single part of your website was under traffic. Maybe it's like a booking engine's under traffic on Black Friday or something like that. But your marketing pages and your newsletter signups are still roughly performing at BAU levels. By taking a microservice approach to architecture, you can split those services out into individual applications. That means they can scale individually. So they can scale with your customer needs individually rather than you having to scale the whole thing. You can also start to look at right sizing at this point, meaning that you attach cloud resources, which are directly attached to physical assets and cost you money and produce carbon, to individual services and make sure that they are the right size for those particular needs. And then you can look at what your BAU traffic would be, and then using techniques like auto scaling to scale these services up or out if you're under traffic. And again, this from a back-end perspective and an infrastructure perspective is where you'll start to see some significant benefits. The next one is around CDN usage, and it's important to, and we've already talked about this, but start serving your assets close to your users to reduce network latency and carbon across requests across the internet. And this could be statically generated pages, but it could also be like cached API responses. You can cache all your API responses on the edge as well, and having sensible cache policies around that will again reduce cost of infrastructure, increase performance, and you guessed it, reduce carbon emissions. The next point is around bots. Now, this is one of the stats when I was doing my research that I found most like revolutionary. But Imperva, I'm not sure if you've heard of Imperva, but they are a big CDN edge provider. They publish something called the Bad Bot Report yearly, and in 2021, the Bad Bot reported that 57.7% of all traffic to websites was human. So that means there's a significant proportion that's made up of non-human traffic. From the rest, 14.6% was good bots. That's things like Google and stuff like that, searching your page for, indexing your page for SEO reasons. and then 27.7% was bad bots. That's bots scanning for vulnerabilities, scraping data for marketing without consent. It could be all sorts of stuff like that. And if you block these, which you can do if you've got a firewall in front of your applications, you can obviously save a significant amount of traffic to your site and also reduce your carbon emissions. So simple firewall rule: block all bad bots. Most modern firewalls, WAFs, web firewalls, will have this rule out of the box, and it's something you should definitely implement, not just from a carbon perspective, but from a security perspective as well. Next point is around turning off non-production environments out of working hours. So say, for example, you've got test environments or UAT or staging environments, you should look to deactivate them if they're not being used, especially if you're not in a period of like constant improvement and you're only in BAU patching mode only, then you should only reactivate them when you're actually using them. And the last point is around adapting cloud native design patterns. So cloud native is the use of Kubernetes and products from the CNCF, and by splitting your applications up into nodes and pods and attaching separate resource plans and scaling those pods horizontally or vertically, you can have very similar effects to how microservice architectures work for your applications. Okay. Number 8. How am I doing on time? Perfect. Okay. Don't forget to patch. This is a good one. This is a quick one, but like also a real critical thing to remember to do. Patch your applications. You're obviously going to get security improvements. You're going to have performance gains, and things are going to work quicker, and they're also going to be optimized more. So by fixing those bugs and tackling those bugs and upgrading those packages, you have a significant benefit from a carbon perspective. And this is guidance that come from everybody's sustainable systems design practices, from Microsoft through to Google through to AWS. Right, number 9, do use design patterns. Now, I love a design pattern. I'm a software engineer. I try to talk to my wife in design patterns and use them to solve everyday problems unsuccessfully all the time. But this is a good one. This one here is called the circuit breaker pattern. It comes from electronic engineering, a bit like a normal circuit breaker, where if you get too much traffic, or if you get something that's not responding in a downstream system, you break the circuit and you stop traffic hitting it. Now, it's very popular in microservice architecture, and it falls under the category of sustainable design patterns. These are a thing, right? Sustainable design patterns are now a thing for software engineers to look at, to take web software engineering techniques and design patterns and apply them to your systems to reduce carbon. So typically with microservice architecture, you have a bunch of services that request each other. If there's an issue downstream, you can end up with like slow network connections, timeouts, or 500 errors, like servers being unavailable. Now, the traditional way of solving these problems would be to try and recall these services until you got a response, but that can obviously result in a huge amount of carbon emissions because you're constantly recalling something that's not working or waiting for it to come back to life, which is obviously a bad thing from a performance perspective, from a cost perspective, from your infrastructure point of view, and from a carbon perspective. So enter the circuit breaker pattern. Circuit breaker pattern itself has 3 steps. As a closed state, everything's hunky-dory. All of your requests are flowing between your client and all of your downstream connections absolutely fine. Then say, for example, on the right here, the supplier microservice has an issue. Then the circuit breaker pattern will form into an open state, meaning it won't make continual requests to your supplier microservice and only make them periodically. And this is when it goes into the half open state. And at that point, it will try to make a request. If it doesn't succeed, it will go back into the open state and then periodically try again, rather than constantly polling that service. Okay. Number 10, where and when you process data makes a difference. So not all data centers are created equal. If you start to look at your cloud providers and you look at the regional maps, you'll see data centers benefit from a bunch of different initiatives, from zero waste, meaning they recycle all the waste that data center produces, or being water positive. So data centers use a lot of water and they take a lot of water out of communities. And if you look at the case studies from Arizona, for example, the amount of data centers there, you'll see local people are trying to make a difference or trying to make data centers change their ways because it's having a significant effect on local reservoirs and lakes. So if you go onto your regional maps, you can see the initiatives in place. And here's an example from West Europe in Azure, and you can see this box at the bottom where it says sustainability, and you can see the certificates that that particular data center is using. Now, by picking the right data center, this is something known as carbon aware computing. And when earlier on we were talking about the reporting dashboard I mentioned, that will also show you where your resources are by region and which ones of those data centers benefit from these sort of schemes. You again should be trying to host your applications in sustainable regions. The other thing to think about as well is batch processing. And much like when you get advice from the government saying you should only be using your washing machine out of peak hours of electricity, it's much the same with when you're batch processing large volumes of data. You shouldn't be processing them within core hours, but you should be processing them out of hours when there's less pressure on the grid. I said 10 do's and don'ts, but I've chucked in an extra one at the end just to keep you all on your toes. If there's 3 things you remember from today, these are the 3 if there's 3 things you're going to remember from this talk today, these are the 3 takeaways. The first one is that the systems we design have an impact on the environment, and the time to act is now. Number 2 is that your HTTP request and processing data produce carbon emissions. And the last one is, if you optimize your system, you'll be saving money, you'll be increasing your users' performance, and you'll be reducing carbon emissions. Now, we've wrote a report on this, and if anyone's interested, there's a QR code on the screen now, and I can share this later on with Yanis as well to distribute. But this is on decoupled systems and the benefits from a carbon perspective, as well as marketing and operations. Thank you very much for your time. My name's been Andy. Cheers. Thank you.
Hey, you made it just on time. That was a really good talk. Thank you so much, Andy, for giving us 10 things plus a summary with 3 things. Lots of good insights. I'll make sure to type this up and share the slides. I think that's